Hello, my name is Daniel Findleton, and welcome to part 2 of the OntarioTech INFR 3110U Game Engines Design and Implementation Midterm Exam presentation. Here we will be talking about the plugin that I made to save our checkpoint times and results. So the plugin itself is fairly simple. It works off of this class checkpoint, and it keeps track of the total time and the runtime between checkpoints. And then we have a few simple functions, such as resetting the logger, saving our checkpoint times, getting the total time, getting the checkpoint time, and getting the number of checkpoints. So these are all defined in our checkpoint.cpp. Reset logger sets the total time to 0, and we create an empty vector of floats and swap it just to make sure that we are properly, quickly and properly clearing the data, and then we are removing the excess memory with by clearing our temporary vector. When we save our checkpoints, it's fairly simple. We simply push our runtime between checkpoints to our list of runtime between checkpoint values, and we increment our total runtime by the current checkpoint. Get total time simply returns it. Get checkpoint time will return a specific RTBC from our vector, and if the index is not within the boundaries of our vector, we would return a -1. And get num checkpoints just gives us the size of our RTBC vector. We then recreate most of our we create wrapper functions for our class, which is what the API will use to interact with the class from the C++ side. We use the extern C part to so that the compiler will, instead of compiling all of this in C++ code, it will compile it as C code. Here you can see that really the only thing that our functions do at this time is that it calls our class, which we have here as CPTimer. Then we simply build our solution as a DLL and insert the plugin into Unity. So here we have the C# code, which we use to interact with our plugin. Once we have drag and drop the plugin into Unity, and Unity starts running an instance of our plugin, we need a script that will interact with our plugin. So we start by defining our plugin names. I have this really long name, but I'll be sure to grab the right plugin. Next, we use these DLL imports to signify that these functions are defined externally by our plugin, and we need to make sure that the functions themselves are identical to our wrapper functions, which we use to interact with the C++ class. Then we have we have interactions for all of our wrapper functions that we defined before. And then we have some functions that we use to further control our interaction from the unity. So in the play scene, we have a checkpoint time controller, which has this script attached to it, and which is referenced by our individual checkpoints, so that every time we run into the checkpoint trigger, we will call save checkpoint time, and our function will take the time that we need and then call save checkpoint time, putting in the delta. We also keep track of the last time, and we update last time to whatever our new time is, and find the difference between new time and last time to get our delta, which we send to save checkpoint time. We also have a function which builds a list of floats, because Unity does not use vectors, but list was a close approximation. So in my function, I get the number of checkpoints that are available, and I simply collect one checkpoint RTBC at a time, and I add them to our list, and I will return that list to be used by our results page. Then we also have get total time, which just gets the total time, and then we have reset, which calls reset logger, which resets our class. Finally, we just have on start. We will always set the last time to whatever the current time in Unity is at that moment, so that we are always starting from 0, basically. And that's it. That's our this is the script that we use to interact with our plugin. In the next video, we will discuss how the random generation algorithm works,